Hey guys, hope you're having a good day today, and hopefully we'll get through these polar coordinates today, and you'll see that they're not just too terribly hard, but it's really going to set us up for the next video over this section, which will be we'll be working with polar equations. We'll have to get good at that. I know we're jumping all around chapter 8. If you're following my little numbers down here at the bottom as far as sequence goes, we did the first part of chapter 8, we did the end of chapter 8, now we're going back and doing the middle of chapter 8. But I like the order in which we're working these problems or working these sections now. Just seems to make more sense to work it in the order I have it. Okay. All right. That we're getting rid of the XY graph. All right, the Cartesian coordinate plane, all those little rectangles, boxes, however they print off, all the graph paper that you have left over that you were planning on using for the rest of pre-calc B. Well, hang on to it. We might make it to that. But for now, I have included this guy right here. This is called a polar graph. I've made a bunch of little polar graphs and put them on a Google document, and it should be in with this video. So that's something, if we were in class, I would have a stack of 100 of them. You just go up and use them. If not, you guys are going to have to print them off or draw your own or just kind of wing it, I guess. And so I just need them to look good, okay? And all we're going to worry about today is being able to plot points on this new polar graph. Now, on a polar graph, I don't have x, y points. Instead, I have r theta points. Okay? And the r and the theta means the same thing that it did back whenever we did the complex numbers. The r stands for the radius, or the length that I am from the pole. And the theta stands for the direction that I'm going, or the direction that r is in, kind of like the angle at which it is from the positive x-axis. That makes sense. Okay, now, well, I just said pole. What is the pole? Okay, the pole is going to be, I'll just say, what was the origin? It was the origin. And so that's going to be this spot right here. So when you hear me talk about the pole, that's just where the origin was a while ago. All right? Now, though, we have all these circles instead of all those boxes. And then I'm really interested in the polar axis. I'll just call the polar axis, I'll say, what was the positive x-axis? What was the positive x-axis? So my polar axis is just going to be that blue line right there. And that's good because that's what theta is going to be measured off of. So theta is going to come up from here like it has been doing. So nothing really new here. I've just got a bunch of new vocab that I'm pushing out on you guys to be able to recognize. Okay. So let's talk about how to graph it because yeah, it's going to look weird. It's going to be a number followed by an angle. Well, what makes the most sense to me is to deal with the angle first. Okay? Well, I like to say, well, I'll just go pi over 2 units. So that just means I'm going to start from the pole right here, and I'm going to go over pi over 2 units. So that my point is going to be somewhere on this terminal side of that angle that ends at pi over 2. To figure out where, that's just how many radii I go from the origin. So I just count up 1, 2, 3. And that would be where that point is. Not too bad. You just have to totally rethink what we have done. So let's go again. Let's do 2 pi over 3. Again, I like to start at pi over 3. Here's my pi over 3. So I'm going to be somewhere on this terminal side of that angle. And if I'm just going to count up 2, 1, 2, this time, just go. Now, I know you've got some extra lines in there. I actually plotted every 15 degrees or every pi over 12. You're just going to have to ignore some of them. We're going to need them later, but just not yet, not right now. So what if I throw you a curveball and give you a negative? see the negative r. I see the pi over 6, it's just this angle right here. If it's negative, see normally it would have ended somewhere on that line. If it's a negative 2, instead of counting 1, 2, and ending right there, I got to go negative 2, 180 degrees the other way. That's where C is going to be. So this would have been positive 2. This would have been negative 2 if I just go to the other side of the pole. Think of it as a number line right here. All right? And so here was 1, here was 2. Negative 2 is in that spot. There's negative 1, there's negative 2. That was kind of weird. What if I make it so the angle's negative? Well, that's not too bad. If I make it so the angle's negative, instead of just going up pi over 6 and going counterclockwise, remember if I have a negative angle, that's one of the first things that we talked about this semester, I go clockwise from there. And then I'm going out. This has 3. 1, 2, 3. Oh, that's my eraser. Right there. And that would be where D is. All right, you've got E. Go ahead and plot E, and then I'll put mine on there as well. We'll see if it's on the same spot. I got mine right there. Now, last year they wanted to complain and moan about, oh, Mr. Lovelady, you didn't put the pi over 4 on there. Well, if we don't know that pi over 4 is between the pi over 3 and pi over 6, we're a little bit behind. But yeah, if you want to print off your graphs and put all these little pi over 4 angles in between there, go for it. This is just what I found on the internet. It's one of the best ones I found on the internet that had the most, that you're going to be able to see stuff on. And so this is exactly what I think I have in your Google Doc. And I got like 6 of them per page. So a lot of your homework is plotting points tonight. Okay? And that will be on your upcoming assessments, on your quiz and your test. I will fully expect you just to be able to go through and, boom, plot a little point. Okay? Now the other part of this, it wants us to be able to convert from polar coordinates back to rectangular. Okay? So remember, on the polar coordinates, I have all these r's and thetas. On the rectangular coordinates, I'm switching this back to the x-axis and this back to the y-axis. Okay? Now I'm just going to pick a random point out here. I'm just going to pick this spot right here. And so I want to show you how similar this is to what we have been doing. Okay? So if I just pick a random spot out there and I'm back on the xy plane, that means I went x, that means I went this far in the x direction, I went this far in the y direction, and then I have the radius of what would be my circle going around. Hopefully that r makes more sense as to why that's radius now, because it's how many radii I went out. So that means that if I am working with theta, which I'm going to put theta down here next to the origin still, that my cosine theta is going to equal, what's that, x over r, giving me a formula for x. Is this something familiar? The same formula we had whenever we were doing it with complex numbers. Same thing's going to happen down here. The sine of that theta is going to be y over r, giving me a nice, clean formula for finding out what y is as well. So if they just tell me what r theta is and they want me to switch it to x and y, it's just, boom, plug in r there, plug in theta there. That's going to tell you the x value. And do the same thing for the y's. Okay? So let's try it. They told me some r's and thetas. I'm wanting to plug them into my formulas, which were hopefully already on my note card. Okay, so to find out what x is, it's just going to be my r, 3, times the cosine theta, cosine of pi over 2. Well, cosine of pi over 2 is 0. 3 times 0 is 0. So my x coordinate is going to be 0. 0 what? Let's plug it in to see what it's going to be for y. And for y, you got to use sine on this. So it's going to be 3 sine pi over 2. Well, sine of pi over 2 is 1. 1 times 3 gives me 3. So I get the point 0, 3. Only have that makes sense to you. All right, I'm just going to do a rough sketch of it. All right, so 0, 3 I know is 1, 2, 3 right there. Okay, well, let's see where 3 pi over 2 is. If I go pi over 2 units, oh wow, I landed right there. And if I go out 3 circles on this, 3 radii, it landed in the same spot. So we're just overlaying an xy coordinate on top of that polar graph, or vice versa, and seeing where these points interchange at and where they would be on each graph. All right, you guys got part B. Let's hit pause on the video. And then you don't have to do a sketch of it like I did, unless you just want to have it make sense to you. So I'll work it, and then you guys do the same. We'll meet back up. Cosine and sine and tangent of all those nice angles that we took 4 pop quizzes over still are not going away. They happened again right here. Got to know those values, and I want those exact values. So there's my answer. Let's just go the other way, talk about going the other way, and then we'll be good. So what if they give me rectangular form? So they've landed at this spot right here, this xy, and I want to change it to r theta. If I know what the xy is, the only way to get my hands on this theta right here is using the opposite side and the adjacent side. So I've got to use tangent to help me out right there. And to get my hands on the r, remember this is just a right triangle. So Pythagorean theorem should get me there. So very similar formulas to what we had in the last section with complex numbers. So I'll try this 3, 3. So 3, 3. We convert it to polar coordinates. Okay, so let's see. Let's just do r first. Okay, my r is just going to be the square root of x squared plus y squared. So 3 squared plus 3 squared. Like I did this in a previous video. So if 9 and 9, that's the square root of 18. Square root of 18 is 3 square root of 2. Okay, so I know that 3, 3 lies up here. So it must be 3 square roots of 2 radii away from the center. Now to get my hands on the theta that I'm making, I don't think this one's going to be very hard to figure out that my theta is going to be pi over 4. But let's talk about how to get there in case it's not quite as obvious. And so tangent theta would have to equal my y over my x, which in this case is going to be 3 over 3, which is 1. I take tangent of what angle, and it gives me 1. Well, pi over 4 and 5 pi over 4. But look where my point is. My point is definitely right here in the first quadrant. So I want my pi over 4. Don't leave your answer like that. I want the nice little coordinate pair, 3 square roots of 2, comma, pi over 4. I don't think they're going to be as nice to you in the homework as I just was. Isn't that terrible? So let me make up a nastier one. Yeah, let's do like maybe 7, 4. Just made that up, all right? If you guys were in class, I would have asked you. Nate Mangum would have said something about a 7, and then I would have included it, all right? So just plotting that, negative 7, 4 should be somewhere around right here. Okay, so again, I don't think the r is going to give us very much trouble at all, ever. So I just have the negative 7 squared plus 4 squared. Oh, 49 and 16. Make sure I don't have any math mistakes. 65. Square root of that. Oh, I don't think that breaks down. Of course, 4 doesn't go into it. 9 doesn't. 16 goes into 64. It's close. I think that's it. So that is my r coordinate, the square root of 65. Just leave it like that. The tangent's going to be what I'm afraid it's going to throw you guys off. Again, it's y over x, 4 over negative 7. Okay? So that means I'm going to have to take tangent inverse of negative 4/7. Because negative 4/7 is not one of my nice ratios that I've been playing with. Now, my calculator is still in degrees from doing law of sines, law of cosines, and I think it's going to want it in radians. So I'm going to switch it real quick to radians. And I'm going to hit second tangent. It gives me tangent inverse of negative 4/7. And that gave me negative, we'll just say 0.52 radians. That's not good. Okay, now first of all, I'm not going to go back and redo this whole video. Negative 7.4 is up here. It was right in my mind. I was going to do a third quadrant one, but it was going to work like the previous one. So yeah, let's move that point up there. And negative 0.52, remember, this is going to be negative 1.57, negative pi over 2. So this angle that they gave me is somewhere like right here. That's not good. But remember, tangent inverse, it gets closed in because it can only go to pi over 2 and then down to negative pi over 2. So that's why it gave me a spot right here. What I need to do on these is this reference angle that comes down to here is the same as this reference angle that comes up from pi. So if I just simply, got arrows going everywhere on this, but if I just simply add pi to my answer, it should put it in the correct quadrant for me. So I'm going to do my answer plus pi, and I get 2.62. That, ooh, this is like, oh, that's going to be my answer on this. So a little DHS easy button action for you. If it doesn't give you a decimal that's in the right spot, just keep adding pi till it does. You'll either, if it's not in the right spot, if it's not in the right quadrant, you'll either add pi 1 or 2 times in order for that to work. And the reason that we have this easy button is thanks to tangent right here, and the fact that tangent has a period of pi units. All right, so plotting some points, doing some conversions, get good at this because we're going to have to jump up from doing points to doing equations tomorrow or the next day whenever you watch this video.